So this is the ice cream and Doritos worksheet. It's the second worksheet in this chapter. Part A, your class is hoping to find the percentage of people who prefer vanilla ice cream over chocolate ice cream. Each group is asked to survey 250 people. In your survey, your group found that 198 people prefer vanilla ice cream. So we need to calculate the percentage. 198 divided by 250 gives us 79.2%. Now we have no idea what's in the box, so we just pretend that 0.792 is correct, and those are the ones. And then we also have to put in 0.208 zeros. No. Nope. So we usually just put the yeses first and the no's second. And really, we don't even use tickets anymore, right? We've decided that we don't need them. We have evolved to the point where we don't need them. What is your best estimate for the true average of people who, or that should say percentage, of people who prefer vanilla? 79.2. That's as close as we can get if we did our survey correct. So we need the SD of the box, which will be the square root of 0.792. And I'm just going to start doing this, 1 minus 0.792, because it turns out I don't even care what that is, right? The only thing I need that for is to calculate the SD, but I can do that by using 1 minus the percentage we have. Now, that will give me my SD, which is 0.4. But what I want is an SEP. How do I convert this into an SEP? Divide by the square root of 250. And also, eventually, we're not even going to care about this number anymore. All we want is 79.2% plus or minus 2.6%. And yes, it took us 6 months to figure out what that means. That's life. A 95% confidence interval. So we take 79.2 and we add that to 2 copies of our SE, which is 2.57. And then 79.2 minus 2 times 2.57. So from 74.06 to 84.34. Is there a 95% chance that that is correct? Careful. Is there a 95% chance that the true average is somewhere in there? No. The chance is either 0 or 100, right? There is a true percentage out there, and my confidence interval is either right or it's wrong. So we can't say that there's a 95% chance that it's correct. What we do say is, this is my 95% confidence interval. I am 95% confident that I will capture the true percentage, which might seem like semantics to you, but it is kind of important, right? It's either right or it's wrong. I just have a 95% confidence. How do we create a 99.7% confidence? Well, we just increase by another SD, another SE. So I'm going to add, or I'm going to subtract 2.57 from this one. And then I'm going to go up here and grab that one and add another 2.57. So from 71.49 to 86.91. And I can keep going out as far as I want. In fact, I am 99.999999999% sure that the true percentage is somewhere between 1 and 99. Not very useful, right? So you kind of have to balance how accurate you want to be, how willing are you to be wrong, and that determines what you multiply this by. But we'll find out later, you need to choose your multiplier before you do the survey. Okay? If originally I was going to do 2 SEPs, and then I calculate that, and I'm like, yeah, never mind. I'm going to change that to 3. That's bad form, Peter. Not allowed. You have to choose your confidence before you do the calculations, and you have to stick with it. You're welcome to change your confidence interval as long as you do a different survey, which might seem weird to you, but that is considered statistically sound. Using your knowledge of normal curve, we can calculate a confidence interval of any percentage we want. So if I wanted to do a 98%, I go to my z-score table, and I look up 0.98, which is 2.32. So I multiply this by 2.32, and I add and subtract it to 79.2. So 79.2 plus 2.32 times 2.6. And then I do the same thing, but I change it to a minus. And I get those numbers, 73.16 and 85.23. Okay, what if I wanted an 85% confidence interval? Well, I just look at my z-score table, and I go to 85%, which is 1.44, and I do the exact same calculations. I just change my z to 1.44. Nope, that's not what you do. This calculator is so slow. Sorry, guys. So 1.44, and then we do the same thing. Change that to a plus. So 75.46 to 82.94. Okay, a 25% confidence interval. I go to the z-score table. 25 is 0.32. So I change this to 0.32. And I get 80.032. Oh, those are backwards. Oh well. And then I change this to a minus. So 78.37. I am 25% confident that the true percentage is somewhere between 78.37 and 80.03. Now, is that useful? Maybe. I don't know. I have a 1. I'm only 1 in 4 certain. Now, again, the probability that I'm right is either 0 or 1 because the true percentage does exist. But I am 25% confident that I have captured that true percentage. Yes. That's fine. As long as you show your work, that's good. My recommendation is don't round anything until the end. The more you round and the sooner you round, the further your answers will be from mine. But as long as you show your work, I'm happy. I can follow what's going on. Okay, number 10. How does a confidence level change the width of a confidence interval? Good. If your confidence level increases, your interval gets bigger. And if your confidence level decreases, then your confidence interval decreases. Yeah. Yeah, I think that I can't think of an instance where that wouldn't work. So yes. Number 11, assume that there are 10 groups in the class and each group conducts their own data gathering of ice cream preference. The class average is 78.5. Calculate a 95% confidence interval for the true percentage. Okay, so I'm going to get rid of all of this stuff and keep our original confidence interval. So the class ended up with 78.5. And there is another percentage over there, but turns out I don't even need to know what it is. So my my expected value is 78.5 plus or minus whatever the SEP is. To calculate the SEP, I find the SD, which is 0.785 times, and then the people who liked chocolate need to go right here, but I'm not sure what that is. I'm just going to do parentheses 1 minus 0.785. Now I need to divide that by the square root of the number of draws. And now we have 250 people in each of the 10 surveys. Do we have to worry about my survey overlapping your survey? No, as long as what? As long as the group size is much bigger than the number of people we surveyed. If there are only 500 people, do I need to worry about my survey overlapping your survey? Yeah, that could be a problem. But if you're surveying 3 million people and you only talk to 2,500, it turns out we don't care if we replace or not. So this is 2,500. And I get 0.8%. So it's plus or minus 0.8. But I want to create a 95% confidence interval. So I need to double this, which is 1.6. And I do 78.5 plus 1.6 and 78.5 minus 1.6. And I am 95% confident that the true percentage is somewhere between 76.9 and 80.1. Okay. Then the last question on the page says, how does this interval compare to this interval? What do you notice? It's a lot. The confidence is the same. The 95% is the same. But the distance is much narrower, right? So this is a distance of 3.2, right? Which is double 1.6. And then the other one is a distance of 10.28. So why is this number so much smaller than this number? What's that? So, so one way to shrink your confidence interval is to increase the draws. You can either decrease your confidence, right? If you want a narrow band, you either decrease your confidence, which doesn't sound like a really good idea, or you talk to more people. So the more people you talk to, the narrower your confidence interval is going to be, and the less confident you are, the narrower it's going to be. So if your confidence interval is really big and you don't like that, you can do another survey and either talk to more people, which is probably a good idea, or decrease your confidence level, which is probably not a very good idea. If you're at 95 and you say, yeah, that doesn't look good, I'm going to drop down to 60%. Probably not a good idea. Okay. The only time you would change your confidence level is if you wanted to become more confident, not less. All right, next page. Doritos. Your class is hoping to find the percentage of people who prefer nacho cheese Doritos over Cooler Ranch Doritos. It's not even a competition in my mind. Each group is asked to survey 300 people. In your survey, your group found that 105 people preferred nacho cheese. That's high in my mind. Nacho cheese Doritos are a subpar snack compared to the Cooler Ranch. So we need to create a percentage box. 35 exactly. So 0.35, and again, something else. I don't know what it is. And it turns out I don't care. Okay, I do know what it is, but I still don't care. So that's the box. What's our best estimate? 35%. Calculate the SD. So the square root of 0.35 times 1 minus 0.35. So the SD is 0.477, and I'm going to divide that by the square root of 300. And I get 35 plus or minus 2.75. So if I want a 95% confidence interval, I'm going to double this, which is 5.5. So 29.5 up to 40.5. That is my 95% confidence interval. If I want a 99.7, I just add another SEP to both sides, or add to the right, subtract. So this would be 46, and this would be 24. Okay. And then you can do a 96%, a 74%, and an 11%. Ooh, let's do the 11% together. That's got to be fun. So on our z-score table, 11% is 0.14. So 35 plus 0.14 times 2.75. And then the exact same thing with the subtraction. So I am 11% confident that the true percentage is somewhere between 34.6 and 35.4, which is true, but that's just not very reliable. Okay. All right, 22. Assume there are 10 groups in the class, and each group conducts their own data gathering, and we end up with 36.1 for vanilla. Oops, that should say nacho cheese. Create a 95% confidence interval. So I'm going to leave our original percentage, and I end up with 0.391 and something. So the square root of 0.391 times 1 minus 0.391, and then I need to divide that by the total number of draws, which would be 3,000. And I get 0.89%. So I double that, and I get 39.1 plus 1.78, and then 39.1 minus 1.78. And I am 95% confident that the true percentage is somewhere between 37.2 and 40.88. And notice that is much narrower than this. This is 3.5, has a width of 3.5, and this one has a width of 11. So The more people we talk to, the narrower our confidence interval. Now, we're going to find that eventually you can actually talk to too many people. Not in this case. In this case, the more people we talk to, the closer we get to the true average. But in future chapters, we are going to do these statistics and basically say, does this drug work, yes or no? Well, in that case, if you ask too many people, you might get an answer that, while true, is actually not very useful. So we try not to, we don't talk to 50,000 people anymore. It's just not worth it. Okay, that's it.